Welcome to Assembly and Operation of the Plasma Demo Kit. I'm Andrew Saltzman with the Massachusetts Institute of Technology Plasma Science and Fusion Center. All plasma demo kits should contain several large components, including a two-stage oil-sealed vacuum pump, a plasma globe, and a spectroscope, as well as a number of small components. If you've received a pre-assembled plasma demo kit, your kit should contain a bag with a number of small components in addition to the three large components listed above. These components will include a pre-assembled Crooks tube, a pre-assembled vacuum chamber, including one steel nut and a spherical magnet, a vacuum hose, two jumper leads, a battery and battery holder, a preformed length of copper wire, a spherical disc magnet, 3 or 4 small neon lights, a small tripod, a 12-volt power adapter, a high-voltage pulse generator, and depending on shipping, you may have received a plasma demo kit containing a small vial of wet sodium hydroxide and a wooden swab. If you have ordered your own parts to construct a plasma demo kit, or have received an unassembled plasma demo kit, your bag will contain a number of small parts necessary to construct the Crooks tube fluorescent screen, the Crooks tube vacuum chamber assembly, a vacuum hose, and a vacuum chamber assembly. An inventory of the plasma demo kit components may be found within the Excel document on the Google Drive folder. All plasma demo kits will include a two-stage oil-sealed vacuum pump. You will receive your vacuum pump within a shipping box. Before operating your pump, it is necessary to fill it with oil for proper operation and to prevent damage. You will receive 2 small containers of oil within the box in the pump. The oil is then filled into the vacuum pump by removing the exhaust filter by unscrewing it from the top of the pump. Oil may then be filled into the exhaust port. The proper level of the oil should be halfway between the minimum and maximum fill lines. This vacuum pump will achieve approximately 20 millitorr of vacuum level. If your vacuum pump is not drawing a vacuum after assembly, please ensure that the vent valve at the side is closed. When operating your pump, several ways to damage your pump are running it without oil, as oil is necessary to seal the pump vanes against the casing and to lubricate the rotating parts. Overheating the pump. If the pump is too hot to touch, turn it off and let it cool. As well as operation with old oil. The oil, visible in the oil level window, should be of a clear color. If the oil becomes dark brown, it should be replaced. You or your students will construct a vacuum chamber as well as a vacuum hose assembly to connect your vacuum chamber to your vacuum pump. The vacuum chamber has 2 metal screws feeding through the rubber stopper. These metal screws allow generation of a plasma within your vacuum chamber after the background pressure is lowered by evacuating the volume with the vacuum pump. To assemble your vacuum chamber and vacuum hose, you will need to locate your syringe body, a twist lock luer fitting, a vacuum valve, a length of rubber hose, a flare nut, 2 fiber washers, a plastic bushing, and a rubber O-ring. The 2 fiber washers are inserted over the plastic bushing. This is then inserted through the flare nut. The cylindrical end of the plastic bushing is connected to the vacuum hose. The rubber O-ring is then inserted into the flare nut, allowing the plastic bushing to seal up against the flare connector on the vacuum pump. The rubber hose should be cut in half in the middle, and the vacuum valve should be inserted onto the hose by pushing both ends of the hose onto the barbs on either end of the valve. The valve is open when the handle is parallel to the vacuum line. The vacuum chamber end of the line should be pushed onto the hose barb of the luer lock fitting. To assemble your vacuum chamber, you'll need to locate a syringe body. If you have a syringe that has a plunger in it, the plunger may be pulled out and discarded. The two stainless steel screws should be inserted through the two holes in the rubber stopper. This provides an electrical circuit to the inside of the vacuum chamber. The two nylon bushings should be inserted over the threads on the stainless screws. This prevents a plasma discharge from forming near the stopper. Two Teflon O-rings are then inserted over the screws, separating the nuts from the nylon bushings. This prevents damage to the nylon bushings by contact with sodium hydroxide while in a plasma. After the Teflon O-rings are inserted on the screws, the nuts are threaded over the screws and tightened. This pulls the head of the screws up against the outer rubber surface and creates a vacuum seal. The stopper assembly is then inserted into the syringe body. This completes the vacuum chamber. For future demos, you will also require threading one stainless nut onto one of the threads, which will allow you to stick a spherical ball magnet onto one of the electrodes. This completes the assembly of your vacuum chamber. During spectroscopy experiments, it is necessary to add a drop of wet sodium hydroxide to one of the nuts in the vacuum chamber. The nut furthest from the rubber stopper should be used as this presents the greatest visibility. Using the cotton swab, dip this in the wet sodium hydroxide and place the liquid on one of the nuts. It should adhere to the nut, and then this stopper assembly should be placed within the vacuum chamber. After performing this demo, the sodium hydroxide droplet should be washed off of the nut, and the stopper assembly should be dried before use in further experiments. To connect your vacuum chamber to your vacuum pump, you will require use of the vacuum hose you have assembled. The protective cap should be removed from the top port on the vacuum pump, and the nut should be tightened finger tight. The other end of the vacuum hose should be connected to the twist lock fitting on the syringe body. Also, make sure this is only finger tight. Remember that your vacuum valve is open when the valve is parallel to the vacuum hose and closed when it is perpendicular to the vacuum hose. The power switch on the pump is on the back end near the fan. You may vent the vacuum in your vacuum system by loosening the lower plastic cap on the vacuum pump fitting. You will generate a plasma in your vacuum chamber by using the plasma globe as a high-voltage, high-frequency electric source. By placing an aluminum foil cap over the plasma globe, you will collect the charge produced and transfer that to one of the electrodes formed by the screw going through the rubber stopper by use of one of the alligator clips. The current return will be provided by a second alligator clip, which will be clipped onto the heatsink fin on the vacuum pump. In order to get the foil to remain on the plasma globe, you may need to use a small amount of Scotch tape. Ensure that both alligator clips are connected to separate screws on the back of the vacuum chamber, and that the screw heads are not touching. The ground lead for the vacuum chamber should be connected to the heatsink fin on the vacuum pump. For the Torella experiment, you will be mounting a magnet within your vacuum chamber. This is accomplished by threading the nickel-plated steel nut onto one of the screws. The spherical dipole magnet will then stick to the top of the nut. Prior to doing this, sodium hydroxide from prior experiments should be washed off of the screw. For your Lorentz force demo, a tin-plated copper wire should be formed to fit within the rivet holes in the end of a plastic battery holder that can contain a AA battery. The wire chosen must be non-magnetic, such that when a magnet is placed next to it without a battery in the battery holder, no interaction occurs between the magnet and the wire. When a battery is placed in the battery holder, current flowing through the wire will experience a force due to the Lorentz force interaction between the wire and the magnetic field caused by the rare earth magnet. The assembly of your Crooks tube can be broken down into three main parts: the stopper assembly, the fluorescent screen, and the needle assembly. The vacuum line assembly should already be present and is identical to the one that you have constructed for your vacuum chamber. To assemble the plug, you will require one 2-hole rubber stopper, one lure lock hose barb connector, a stainless steel cap screw, 2 washers, a nylon bushing, and a nut. The lure lock hose barb connector should be pushed into one of the openings on the rubber stopper. This allows you to pump out the Crooks tube with the vacuum pump. Next, the stainless screw should be inserted through the second hole. A washer should be placed over the stainless steel screw, followed by the nylon bushing, followed by another washer, followed by the nut. This provides one of the electrodes used in the Crooks tube. The second electrode for your Crooks tube is created by pushing a sewing needle through a lure lock plug, which is then screwed into the tip of your syringe. To push the sewing needle through the lure lock plug, place the plug on a hard, flat surface and push the needle through the center of the plug. Ensure to press this straight down, as a deformation of the plastic around the needle creates the vacuum seal. If you bend the needle sideways, this will likely cause a leak at this junction. To assemble the phosphor screen for your Crooks tube, you will need glow powder, a paintbrush, a pair of scissors, a roll of double stick tape, your paper Crooks tube fluorescent screen template, and a roll of aluminum tape. The phosphor glows when struck with electrons. For our Crooks tube, we use europium-doped strontium aluminate. This is sold as glow-in-the-dark powder on Amazon. It is generally considered a non-toxic nuisance dust, so avoid inhaling it and wash your hands after use. To assemble your Crooks tube phosphor screen, first print out the paper template. This template can be printed out either from this PowerPoint slide or from the template slide within the Google Drive. After printing out the template, cut out the outer perimeter of the template with a pair of scissors. This template is then stuck onto a length of the adhesive side of a length of aluminum tape. The aluminum acts as a conductor in the Crooks tube, and as well as provides support for the paper template. After the template is stuck onto the aluminum tape, smooth the back side of the aluminum tape by running your fingernail along the back until there are no wrinkles or creases. Following this, cut out the perimeter of the template from any additional aluminum tape. Cut the slit out from the disc. Then, cut 2 notches on this end of the Crooks tube template and fold over the aluminum ears. Last, fold over a small piece of aluminum tape over the end of the disc, as this provides reinforcement. Next, fold up the sides of the phosphor screen ramp by using a straight, hard object such as the blade of the scissors. Place this along the dotted line and fold both sides of the ramp upward. Now, add an adhesive coating to the fluorescent screen area of the ramp by placing 2 lengths of double stick tape on the ramp. Cut off the excess tape and ensure there is a solid contact between the double stick tape and the Crooks tube fluorescent screen by rolling the paintbrush handle across to ensure the tape is firmly pressed down. Next, the fluorescent material is transferred onto the Crooks tube screen. Transfer a small amount of the phosphor, the glow powder, dry with the brush onto the double stick tape. Place this approximately on the center of the ramp and spread this over the exposed sticky surface of the tape with a paintbrush. Gently tap off any excess phosphor into the trash. Now the Crooks tube may be fully assembled. Place the phosphor screen inside the body of the syringe. Then, stick the rubber stopper onto the open end of the syringe. The exposed nut should be positioned approximately a 1/4 inch to 3/8 of an inch away from the slit and aligned with the axis of the slit. The needle is then inserted into the tip of the Crooks tube, tightening the lure lock plug finger tight. Your Crooks tube will be powered by a high voltage pulse generator. This is powered off of the 12-volt power adapter included in your demo kit. The pulses are generated automatically when plugged in. Don't touch the red lead tips or connected alligator clips when it is turned on. Also, do not turn on the pulse generator unless it is connected to the Crooks tube under vacuum, as it may damage the unit if it is trying to generate pulses but not drawing a spark. Do not run the pulse generator for more than 1 minute at a time or it may overheat. Be careful with this pulse generator as contact with the high voltage spark will hurt. Don't touch the output leads when it is on. A teacher should perform this demo for middle school classes and supervise high school students. The Crooks tube is connected to the high voltage pulse generator by means of 2 alligator jumper leads. One of the output leads of the pulse generator should be connected to the head of the screw in the stopper end of the Crooks tube, and the other end of the high voltage pulse generator should be connected to the needle at the tip of the syringe. The polarity of connecting these leads is not important, as the high voltage pulse generator produces a bipolar pulse. One lead is first positive while the other is negative, followed by the other swinging negative while the other is positive. The Crooks tube will only generate electrons passing through the slit when the stopper end is negative. The assembly of your plasma demo kit is now complete.